Hello, welcome back to the Amit Dhakad AI. In this video, we will learn NumPy. So first, you need to install NumPy using pip install NumPy. After that, you need to import using NumPy as a NP. Okay. So we are importing matplotlib2.pyplot for as PLT. Okay. So this we are importing for and displaying the graphs. Okay. So why we need to NumPy? Instead of Python. So Python is a flexible but slow to work, and every element is full of object and loops. Okay, and NumPy store data as a one continuous block of memory. So how you can create arrays in NumPy? So you have function called np.arrays. Okay, so it will take as a data and it will list of array like 1D array, Python array. So it will convert into the NumPy array. Okay, so here we are passing 1 2 3 4 5 as a array here, 1D array or list, Python list here, and after that we are printing array 1D. Okay, so what is that? It will create 1D array in the NumPy. After that we are creating 2D arrays. How we can create 2D array? Just we have to pass the two list. Okay, so it will be two lists. So it will be 1 2 sorry 1 4 2 5 3 okay 6. So we have one row 1 and row 2. Okay, so this is the 2D array. So if I run this one, okay, we need to run first shell this one. So you can see we have 1 2 3 4 5 here. After that we have 1 2 3 and 4 5. So this is 2D array and this is the 1D array. Okay, so here we have 1D array and we have 2D array. So this is how we can create arrays, 1D array and 2D array from the Python list. Next, we have placeholder and sequence. What it will do? If we want to create like some arrays, okay, in the NumPy. So NumPy provides some functions. Using that, you can create the NumPy array. So we have first np.zeros. So it will array of zeros. What it will do? It will take the shape. Okay. So what you want for that? Similarly we have np.ones. So it will create all the element with the ones. Okay. Next we have np.full. So it will take the shape here and it will take the value. So what value you want to add in the matrix, okay, or in the NumPy array. Next we have np.I. It will be n into n identity matrix. Similarly we have np.arrange and np.linear space. Okay. So we will see the example. We are having np.0 2 by 3. So it will create 2D array with the 2 by 3. So 2 rows and 3 columns. Okay. Similarly, we have np.ones. It will be 3 into 2. Okay. Similarly, we have 2 into 2 and we are passing 7. So this is the create 2 by 2 2D array and it will fill with the 7s. We have np.I with 3. So it will create identity matrix for that. Okay. So if I run this one, so you can see first we are creating zeros. Okay, so you are passing here 2 into 2, 2 into 2 by 3, like 2 comma 3. So it will create 2 rows and 3 columns. You can see we have 2 rows and 3 columns. Similarly, we have 3 by 2 and will create 3 rows with 2 columns. You can see column 1 and column 2. Okay, similarly we have np.false. It will be 2 by 2, but it will be filled with 7. Okay, so similarly you can create this one using, we are doing np into 3 by 2. It will be once, right? So you can use multiply with the 7. So you will get the same results. Next we have np.I. It will create identity matrix. What is the identity matrix? Identity matrix is that where in the diagonal you have all the ones. Okay, so here next we have np.arrange 0 to 10 2. Okay, so what it will do? It will create like array with the 0, okay, 2 4 6 8. Okay, so it will take, this is start step, this is start, this is end. Okay, so in 0 will be inclusive and 10 will be exclusive. Okay, so it will not be included in this one, and 0 is included. Next we have linear similarity, so it will take 0 1 and it will take the 5. So it will do like in the 5 point it will be spaced evenly. It will be similar, but it will take include 0 and it will include 1. So here you can see 0, 0 0.25, 0 0.5, 0 0.75 and 5, 1, right? So we'll get 1 2 3 4 5. So it will be in the 5. Okay, so it will be spaced evenly from 0 to 1 in the 5. So this is how we can create arrays in the NumPy. Okay, next we have data types in the NumPy. So when we create np.arrays 1 2 3, so if we see the data type of this one, okay, so what we will get, it will be float 64 by default. Okay, so here we are creating np.arrays, but we are passing d type equals to np.float 32. When passing d type, we are explicitly saying create this array with the float 32. Okay, similarly we are having default ARR type and float. So if we run this file, you can see we have 64 and float 32. For default ARR, we are checking type, so it is 64, and for this one we are said explicitly it is float 32, right? So it will be float 60 32 for this one. Now we are default.arr dot as a type np.float 64. Okay, so here we are converting this one for this type also. Okay, next we have some other attribute that we can use for debug. So first we have a dot shape. What it will return, it will return the shape in like the rows and column. Okay, we have here 1 2 3 4 5 6, so it will return 2 by 3. We have similarly for dimensional, for size, t type, okay, item size and n bytes. So if I run this one, so you will see we are getting 2 by 3. We are getting dimensional, so it was 2D array, so we will get 2. It will check the size, so you will get the count of the size. We have 1 2 3 4 5 6, right? So we will get the 6 here. Okay, 3 plus 3, it will get the 6 here. We are checking a dot d type. So what is the data type? So you will get in 64, and item dot size, it will be 8 byte. Okay, and 48 total bytes. So this is how you can use this and create. Okay, so you can perform any operation, you can check type and a dimension. Okay, so this is exercise 1. Here you need to create 4 into 4 array with the filled with numbers using two different functions like shape and dtype for this one. Okay, so what it is saying, you need to create 4 into 4. So first you need to create like np.full and 4 into 4, and you need to pass the number 5, right? Next we have two different functions, so this is one. Next we have np.ones, right? So you need to pass the type int for that, and you need to multiply by the 5. So you can see here we are doing same thing, np.full. So here you will see we are passing 4 into 4, so it will create 4 into 4, and it will be with 5. So if we do 5 5 5 5, okay, so it will be 4 into 4 like this. But here we are passing np.ones 4 into 4. So here first we will get 4 4, sorry, 1 1 1. Okay, after that we will multiplying with the 5, right? So it will be element wise multiplication, so it will multiply with the each element like 1 into 5 5 5 5 here you will get the same result. Okay, so this is how we can perform this operation. So if I run this one, so you can see we have 4 into 5 into 5 and 64, and 4 into 4 and 64. Okay, so here what happened if I remove this, so get float 64. Why? Because by default it will be float 64. So if we are creating explicitly, so you need to create the type int. Okay, so it will be. Next we have indexing and slicing and boolean masking. So what is that? First you need to create we have one array with the value of 10, 20, 30 and 40 here. First we are at 0 and ARR minus 1. So it will return 10 and minus 50 first and last element. After that ARR 1 to 3. So what it will take? It will start from 0, 1 and okay 3. So 0, 1, 2, 3 and 4. So it will start from here and it will be till here. It will include the first index, not the last index. It will be less than that. Okay. Here we have 0 to 3. It will be from starting to less than here to the 2. Okay. Next we have 0, 0 for other elements. So what it is saying, like it will take first 0, 2 and 4 like this. We have this, so it will be reverse the list. Okay. So if I run this one, what you will get? You will get all the results. First you will get first and last element. After that 2 and 30 here, right? And here you will get 10, 20, 30 and 10, 30 and 50. After that 50, 40, so it will be in reverse order. Next we have 2D indexing, like how you can use indexing here. Okay, so we have 2D array, np.array 1, 2, 3, 4, 5, 6, and we have 3 rows and 2 columns. Sorry, three rows and 3 columns. Okay, so if you use np.size this one, you will get 3 by 3. So what it is saying? It is saying grid 1 and 2. So it will return grid. It will take row 1 and column. Okay. So next we have grid 1. So it will take the first this row 0, 0, 1, 0, 1, 2. Okay. So we are checking grid 1. So it will take the complete row. Next we have this column comma 1. So what it is saying? It is saying like rows and it will take saying column 1. Okay. So it will take column 2, 5, 8 entire column for this. We are saying this 0 column 2. So it is saying 0, 1. Okay. So it will take in first and second row. After that it is saying 1, and after that we are not passing what it means. It will saying 0, 1, 2. So from 1 to all the columns till here. So we will get the column 1 and 2. Okay. So if we run this one, what we will get? We will get the grid. So you can see we have here 6. Why? Because 0, 1. Okay. After that 0, 1, 2. Okay. So it will be 6 here, the second row, and the third this one. Okay. Next we have 1. So it will be entire row here. Next we are passing like this. So it will be column here 2, 5, 8. Next we are getting the grid from 2, 3, 5, 6. How? Because we are getting from 1 here 0, 1. So we are getting first and second row here, and after that column we are getting from 1 to 2, right? So it will we are having here this 2, 3, 5, 6. Okay, so this is how we are getting. Next we have views versus copies. So how it will work? So first we have np.arrays. Okay, we have two rows, 3 columns here. So what it is saying, original we are getting 0, 1. So and we are using like slash, we are getting data from our original np.arrays, and we are getting here, okay, from zeros 1, and after that from 0 to 2. So like you can 0, 1, 2. So it will be 0 and 1 like this. So we take this one, so it will get view here. So this, so we print this one, what you will get here? So you will get here 1 and 2, right? This one. So what it is doing here, it is assigning view 0, 0 to 99. So it is saying assign on the 0th position. Like if we have any, so here we have 1 and 2, right? This one 1 and 2 here. So what it is saying, it is saying this is 1 and 2. Okay, this is 0. So it is saying assign for this one view 0, 0. So it is the first row and first column, like the 0 rows. It is assigned there 99, right? So we are assigning here. Okay. After that, you can see we are printing here original. So it is printing 999 here, and it is printing 999. Okay. So what it is doing? It is doing when we create view using slicing, it will point to the same array. Okay. So when we perform any operation in this view, so here we performed like update the first column, first element in the first row and column. Okay. So after that we are printing, so you can see it's updated the original one. But next we are creating new copy from this one. So this is software where we are assigning equals to -1. Okay. Safe underscore 0 position -1. But here you can see we are printing original, but here you can see we don't have -1 because when we use copy, so it create new copy of that array. Okay. So if you have faced any issue with the reference or this one, if you want to create new copy, you can use the dot copy. Okay. Next, we have Boolean mask and filtering. So how this will work? We have again one array here. Okay. So it will be 120, 45, 30, 120, and 28. So here cells greater than 100. So it will check where we have value with the 100 greater than 100. So we have first and two. Okay. First, second, and this 0, 1, 2, 3, 4, the fifth index. Okay, other will be false, 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 false. So we will get masks. So if we print, we will get this data. After that, what we are doing, we are passing cells and we are passing this mask to this one. So what it will do, it will return all the data that is followed this conditions. We have true in this one. What? Okay. After that, here also we are directly using this one. Instead of creating a new variable here mask, we passing this direct condition to this one. So both will work in the same base. Okay. Here what we are doing, we are taking cells greater 50 and cells less than 20. Okay. So we are combining this one. So we will get the value based on this condition. So here you can see we got here the mask true, false, true, false, first, true. After that, you can see we have 120, 300, 250. Similarly, here also we have 120, 300, 250. But here we are passing cells greater than 50 and less than 200. So greater than 50 is 120, 300, and okay, sorry, no, it will be okay. So 120, 300, 88, and 250. But next condition we have less than 200. So less than 200 it will come 120 and 80. Both will be removed because these are greater than 200. So we'll get 120 and 88. Right? Next we have indexing here and np.where. So how we use this one? We have np.array. Okay. Here we are having index 0 to 4, and when we pass this index, so it will return the element based on this index. We are passing 0, so it will return 10. Okay. So 0, 1, 2, 3, 4. So we will get 2, 30, and 450. Okay. So this will, we are passing index here, so you can see we are getting this value. Similarly, we have labels np.where we are checking data greater than 50, sorry, greater than 25, high, otherwise low. Okay. So when you print, we will get label what? Here we will get low, here we will get low, here we will get here high. Okay. So here you can see we got 10, 30, 50. Here low, low, high, high, high. Okay. Here we have np.where data greater than 25. So it is checking where we have data greater than 25. Okay. So we have here 0, 1, 2, 3, 4. So we have here in 2, 3, 4th position. Okay. So we are getting index in this one. So this index you can use like this to fetch the data. Next we have exercise here. So we have np dot temperature array here. So what is saying, each boolean masking to pull out the temperature above 80, then report how many days that was. Okay, so you need to check. So we are getting this one. So you need to run mask condition here, like temperature greater than 80. Okay, so it will return here like this, temps greater than 80. Next, it will return like hot days there. After that, it is asking how many days, so you need to calculate the len. So for that, we have len function and you need to pass hot days, so it will run. So we'll get the 3. Okay, 72, 68, 91, 85, 60, 70 and 90. So it greater than 80 is this 91, 85 and 95. So we have some, we can perform operation on the NumPy arrays, okay, and some universal function we will see, and broadcasting. So first we have two arrays here, okay. So we are array A and array B. So we are having here 1, 2, 3 and 10, 20, 30. Okay. So next what we are doing, A plus B. So what we will do, A plus B, all the operation we are doing here will be element wise. So what it means element wise, we have 1, 2, 3, okay, and we have 10, 20, 30. So we have to do here 10 plus 1, 2 here and this one, okay. So we'll get 11, 23, sorry 22 and here 33, right, for plus this we are doing A plus B. Next we have A minus B. So here we will get a negative value like minus 9, minus 18 like this. Similarly a multiplication, so we get 10, 40 like this, and similarly division and a square. Okay, so each element for this one will be this, like this. Okay, so this is the element wise multiplication. So if I run this one, so you can see we are getting same result here, like 11, 22, 33, minus 1, 9, minus 18, 10, 40, 90 here. Similarly 0 0.1, 0 0.1, 0 0.1, it will be like A divided by B, right? And A keep a square 2, so it will be square like 149. Some we have universal function that here we can use those also. So we have some function like square root, exponential, here, and we have log and absolute and round. Okay, so if you square root, so it will be do square root, it will calculate exponential, log for that, and absolute value and round. Okay, so if we run this one, you can see the result here. See, so here what it is saying, here you are getting 1 2 3 4 5. Okay, this is the square root of these, like 1 2 3 and 4 4. Here 0 1 2, so it will get the value for this one. Here log value you will get for this one, okay, like this round. So all these value we have function for absolute value, round, log, okay, so you can use those. So we have next broadcasting. So what is broadcasting here? So what happens when you add array with different shapes? Okay, so NumPy stretch the smaller one without actually copying data, so that the shapes line up with the broadcasting shape. Okay, so what is the rule? Line the shape up on their right edge. Two dimensional are computable if they are equal, if one of them is 1. Okay, and missing dimensional on one side is treated as 1. So if we are having any missing dimension, those are treated as a 1. Okay, so we have matrix and dot array. We have 1, 2, 3, 4, 5, 6, 1, 2 rows, 3 columns. Okay, so the shape is 2, 3. So this will be row and this will be column. Next we have np dot arrays 10, 20, 30. So we'll have 3, right? So if you remember, if we have any 2 by 3, and if we count, this is 3. So these two should be matched to perform any operation in the matrix. Okay, so we are doing matrix plus rows. So what it will do, it will stretch this one to like 10, 20, 30 and 10, 20, 30. This is missing the second rows. Okay, We have here 2 rows and 3 columns, right? Now, similarly, we have here 10 and 20 here. So it is 2 into 1. Okay. So you can see this is also getting addition. Here we have a scalar like single value 1000, and here we are doing addition. Okay. So we add here, we're doing matrix plus row. So this is will be staged like this. So it will be like 11, 22 like this. And here we have plus. So it will be like 1, 2, 3, 4, 5, 6. Okay, so we have this 100 and 200. So this will be added in this one and this will be added this one. Okay, so if I run this one, so you will see the result. Okay, so you can see we have here, you can see here we are having here this one 11, 22, 33. Okay, next we have here same 10, 20, 30 rule. So we are getting 14, 25 and 36. Next we have 101, 102, 103. So what it is saying? It is saying this one adding here 101, 102, 103, but this one is getting added here for 204, 205, 206. Okay, but here you can see we have 1001 because we have only single, so it will be added in the all the elements here. Okay, so you saw we are getting result, but we are don't have all the like missing dimensions we are having. Here we have only twos, right? So it will be 2 by 3, so it will be like 100 and 200. So this is how we can do the broadcasting. Next we have here np.arrays, and what we are doing, we are having here like mean, x is 0 and x is 1. Okay, okay, so here we are having x here. We are calculating x mean based on x is 0. Okay, and next we have x dot standard, x is 0. So what we are calculating on x is 0. Next we have x minus columns divided by column underscore this one. So we have standard deviation here and we have mean. So we are calculating the standardized. So we are printing here, so we will see this. Okay, so you can see we have new column, this one minus 0, minus 0 and 0. So this is based on this one. Okay, so here we are checking like how much time Python will take and how much time the NumPy is taking. So we have had 2 million data, like 2 million numbers. Here we are creating list range Python list and np.arrange function we are using to create the okay, this one. Okay, arrange. So it will create the 1D array with the 2 million data. Next we are using start time. Here we are, what we are doing, we are doing a square for this one. Okay, so each element will be squared and we are checking the time, how much time it took. Next similarly we doing np square, so this will also perform same for operation here. Okay, so if I run this one, so we will see the time difference, how much time the normal. So you can see we have here 0.108 to 20 seconds here. Next we have 0.0048 seconds. So you can see how much fast this NumPy is. Okay, next we have exercise. Here you can perform the same. It is saying add flat 5 piece. Okay, and after that it will saying convert. So you need to just use the use plus here 5, because it will be performed on the element wise. Similarly after that adding plus 5, we need to perform the multiplication using 0.95. So we will get the result. Okay, so you can see we have a result here, and you can see we are using grind to 2 point. Okay, next we have aggregate and statistics. For data we have np.array 1 2 3 and 4 5 6. Here also we can have some function. Those functions we can use to perform operation, like if we need sum, so we'll get using the data dot sum, data dot mean, standard deviation, we have mini and max values. Okay, so these data you get using these functions. So if you run, you can see we are having some 21 mean, 3.5 standard deviation, Okay, mini and max values. So minimum is 6, max is, sorry, minimum is 1, max is 6. Okay. Next we have access parameter. Okay. So you saw above we were using the access 0, right? So access 0 is column and access 1 is the rows. So how this works? So we have np dot array here, right? So we have here 2 by 3 shapes, right? After that, what we are saying, we are saying data dot sum, and we are passing access 0. So it will print the sum based on the column. Okay. So what we have 1 and 4, 5, 2 and 7 and 9, right? And next we have row by sum, right? So we have 1, 2, 3 and like 4, 5, 6. So if I run this one, so we'll get the result based on the access. So we get 5, 7, 9 and 6 and 50, right? So this is the column based, this is the row based. So here we have 3 element. Why? Because we have 3 columns here and we have 2 rows. Here we are getting 2 rows. Next we have percentile and correlation. So this is similarly, we have percentile function. If you pass the array into that function and you will pass the percentile, like which percentile you want, so it will return the percentile. And we have the here hours studied in exam. So here we are checking the correlation matrix between hours and examples. Sorry, exam scores. Okay. So you can use np dot correlation. You can say okay here, and you can pass this one. So you will get 1 and 0, and here you will get 1. We have, so how we can handle the missing data. So in the machine learning, we will get data and that will have missing data. So how you can handle that? So for first you need to find the missing data. Okay. So I have this array here, 98.2, 99.1, np dot nan we are passing here. So we have two none values right here, or you can say missing values. So we have np dot is nan. So it will check if we have any nan value there or not. Okay. After that we are reading mean. Okay. And after that we are reading nan mean, and we are nan sum. So what I will do, so I will run this one. After that I will explain. So you can see you are getting here false false, but here we are getting true. So like we have here nan values like none or missing values. After that we are calling reading dot mean. So when you use simple mean function here on this one and we have missing values, so the mean will also be nan. Okay. You can see we have nan. So that's why if we are having any missing values, we will see nan mean. Okay, so we have 91.5. So what it will do, it will ignore these two nan dots. Okay. Similarly, we have np dot nan sum. So this will also ignore this one, or it will consider as a zeros. Okay. And we have count valid for. So what it will do, it will check if np dot is nan, and after do np dot sum. So it will return the value that is valid. Okay. So it will be false false. This is 1, 2, 3 and 4. We will get the 4. So this is how we can find the missing values and how we can enter. So we'll next we will see how we can like replace the nan values. So we have next function here, like example. So what it is saying, it is saying we have 3 into 3 a student and test row is a student, like this is one student, second and third student, and these are the test result for first students 85, 90, 78, 92, 88, 95. So it is saying find each student's average and each test average. So we already did how we can say we need to pass mean access is 1. So it will return the student. Access 1 is the row. So it will be row 1, 2, 3. So we will get 3 student average. Next we have the test result wise. So we need to pass access 0. So it will be column wise. So you can see we have student wise here 84, 91, 75, and this is the test result. Next we have reshaping and combining and splitting. Okay. So what is that? So here we have np dot arrange. What it will do, it will create 1D array for us. If we print here, we will get 1D. Next we are reshaping array. We are dot reshape 3 by 2, 4. So we will get 3 rows and 4 columns here. Okay. After that we are showing reshape dot reveal. So what it will do, it is saying view then possible. Okay, so it will create view, and we do always a copy. So when we do reshape dot flatten, so what it will do, it will create copy, and it will convert that. This is reshaped, right? So it will convert that into the 1D array. Next we have reshape here, arr.reshape -1 and shape. You can see we are passing -1 to reshape, and here we have shape. So if we have here 0 to 12, right, we have almost 12 elements. So how we can convert that or reshape this 1D array into 2? We can convert into 3 by 4 and 4 by 3 and 2 by 6 or 6 by 2. Like 2 rows 6 column and 6 rows 2 column, right? This is like this. But here we are passing minus. So what it is saying? It is saying NumPy to like calculate for you to which how many rows it is want and column, like how you can reshape that. Okay, so if I run this one, so you can see we have 0 to 1 here. So you can see we are getting originals, but you can see we have here dot shapes. We are getting 12. After that, reshape to 3 by 4. So 3 rows, 4 columns. Okay, so you get this one. After that, reshape dot reverse. You can see same result we are getting here, but this is copied, this is viewed. Okay, so we already saw previously what is the difference and what in which cases we need to use. Here we is shaping -1 into 6. So the NumPy is converting into 2 by 6. Okay, so we are getting this. Next we have transpose. Okay, so what is the transpose? So we are having here np dot arrays. Okay, we have 1 2 3 4 5 6. We having 2 by 3, right? 2 rows 3 columns. So we are checking np dot shape. After that we are using m dot transpose. What it will do, it will convert this 2 by 3 to 3 by 2. So the column is converting into the rows, and rows are converting into the column. So we have 1 2 3 4 5 6. We will have 1 2 3 4 5 6, right? If I run this one, we will get 2 by 3 1 2 3 4 5 6. Okay, and the shape is changed to the 3 4. Next we have combining arrays. We have two arrays here. Okay, 1 2 3 2 rows and 3 columns. We are concatenating, so it will concatenate this one. Next we are using v stack and h stack. What is those? So it will stack the a and b as a row and column. So you can see we are having here, right, concatenate. It will add the single element in the 1D array. Next we are using v stack, so it will stack 1 a and b as a rows. Okay, so you can see we have 1 2 3 and 4 5 6 as a rows. Next we have np.h stack, so it will be side by side, like column by column. We have 1 2 3 and 4 5 6, like we default we have in concatenate. So we have splitting arrays. How we can, we have np.arrange9.reshape, so it will create 3 by 3. Okay, 3 rows 3 columns. So we have np.split grid 3 and np.hsplit grid 3. Okay, we are splitting this. So we are np.split first. So it will, what it will do, it will split in the 3 rows. Okay, so we have here 3 0 1 2 3 4 5 6 7 8. So we will get 0 1 2 3 1 2 3. We will get 3 separate rows, and using this one np.grid state, we are doing np.h split. So what it will do, it will, we will get 3 columns 0 3 6 1 4 7 2 5 8. You can see we have 0 1 2 3 3 4 5 6 6 7 8. Here I have 0 3 6, and we have 1 4 7, and we have 2 5 8. Okay, so this is how we can split the data. Next we have adding and removing dimensions. We have np.arrays 1 2 3, right? We have x shape, so we will see it will be 3 by 1. Okay, so if I run this one, so you can see we have 3 by 1 here, right? 3 by 1. But here you can see we are passing x, here we are passing all the rows, take all the rays, and it will say np.new axis. Okay, so it will add column vector here, so we will get 3 into 1. So we will get 3 by 1, so it will be 3 rows and 1 columns. Okay, You can see next we are using np.expand dimension x is 0. So what is the x is 0 here? X is 0 is the row, and so it will take this as a row and this will become as a column. Okay. Next we have, if you want to the same result like this one, so for that you need to pass here 1. Okay, so we will get 3 into 1, 3 rows 1 column. Next we have squished np.squish. So what it will do, we have this, so it will convert this into the flatten, or you can say remove all size 1 dimension. Okay, and it will be 3 like this. So this one will be removed, so it will be 3 comma only. It means it is a 3 rows. Okay. Next it is saying tribal shape, so you need to convert take np arrange to 3 by 4 array and then into split and right split. Okay, so it will be same only that previously we did in 3 into 4, and we are using h split arr into 2, so it will be left and right. So, okay, so it will, you can see 2 1 2 5 6 9 7 and 3 4 7 8 11. Okay, so it will convert into the 2 columns, one is left and right. Next we have sorting and searching. Okay, so we have np.array. So this data we have np.array sort, we pass this one, so it will return the new array. Okay, next we have np.array sort. What it will do, it will return the indices. Okay, so if we have, so you can see sorted here 1 2 5 8 9. Next original untouched, original will be remain same. Okay, we have original array, this is the new sorted. Next we are using np.arrange here, so you can see we have 301. Okay, so it will return the indices based on the, so you can see 0, right? So we have 0 1 2 3 4, so you can see in the 3rd position we have 1. Okay, so it will, that's why, so for this one we will get the indexes of sorted array, right? And after that you can use the original array to get the data. So you can see we are printing the using that only. We are having original array and we are having indices of that order. So we will get the 1 2 5 8 9. Next we have np.unique. Okay, so data scientist best friend, what is that? It will check the unique values in the data set. We use np.unique, so you can see labels here and return count true, so it will return count also. So what it will, we have classes, values and total counts. Okay, so classes, what is values? Values means we have 0 1 1 2 3, so it will return 0 1 and 2, and count, so it will return count based on that. How many zeros we have? 2. How many? 3 and 3. Okay, so if I run this one, okay, so we'll get 0 1 2 3 2 3 3. Next we have np.assign, so it will membership testing, so it will just check it is present there or not. So we have 5 2 8 1 9 2 9 100. So okay, so we run this one, so we will get true and false. We have 2. Okay, so it will return 5 is present, and like we are not checking 5, right? So it will return false. We are checking 2, so where it is 2 here, so it will return 2 there. Otherwise 8 9 1 we are not checking, so these are false here. We are checking 9, so 9 is present here, so it will replace with the true. Okay, next we have some linear algebra. Like in machine learning, when we create any algorithms or any model, so we need to perform some operation using that. So we have two arrays here. Okay, np.arrays 1 2 3 4 5 6 7 8. Okay, so two matrix. So we have one a dot b, so it will do the dot product for that. Okay, between these, and we have a at the rate b. So we don't want to use the dot function, you can just use the at the rate. Both are same, so in identical to dot for 2D arrays. Okay, next we have np dot multiplication function a comma b. So this is similar to a into b. This is all like element wise. So if you run, you can see we have 19 22 43 50 similarly. Okay, here, but a into b will get 5 12 21. Okay, so these three are same and this is different. So what is the multiplication, like how we can perform the dot product, right? So this is same, like you need to take 1 2 3 4. We have 5, 6, 7, 8. Okay, so for this one, this is column, this is rows. So you need to multiply here like 5, okay, plus 7. This is 5, not 7, it's 14. Okay, so this is 1 into 5 and 2 into 7. We will get 5 into 14, we will get the 19. Okay, similarly, this has become the first element here. Next, we have second column. So in the first row, we have to do similarly 6 and 16, that will be 22. Similarly, same operator need to perform this row. So like this, you have to do dot product. Okay. So this is like why this matters in neural network is a matrix multiplication. So neural network, we use the dot product and other to perform the operation. Next, we have np dot arrays. We have here linear algebra dot determinant and inverse here. So if you can directly solve this one, and if you pass, you will get the determinant and inverse. So what is that? You will get the 5 here, okay, and inverse you will get 0, 6 with this one, okay, and this solve. So here we are passing a and to b. So here we will get the value of x, and you can perform a and into x the dot product. So you will get this value, okay. Next, we have vector, norms, and distance. Okay, so we have two array data again, np dot arrays, np dot arrays 1, 2, 3, 4, 5, 6. We are using np dot linear algebra dot norm. We are passing v1 minus v2. Okay, so this will calculate the equilinear distance. Next, we are printing the. Next, you can see cosine similarity. Here we can see the cosine similarities. We have np dot dot v1 v2 divided by this v1 norm and multiply by the v2 norm. Okay, so what is the cosine similarity? When we create a like machine learning model, drag or anything to match the data, like, okay, so for that we need to calculate. So like if you want to check, we have word king or queen. So if you want to check how much related these, or you have car, okay, so how much the relationship, or how you can see how these can be grouped. So you will be find the cosine similarity in less between king and queen compared to the king and car. Next, we have random number generator. So we generate random numbers in machine learning mostly. So here you can see we have function here np dot random dot default range. So here we have seed equals to 42. What is seed? Seed is the value number that we need to pass in machine learning, because every time we run this model, we will get the random generator, right? But if you pass the seed, will every time if you run this one, you will get the same numbers. Okay. So we have range random number, so it will be getting the data between 0 to 1. Next, we have an random integer, low 0 and high 10 and size 5. Okay. Similarly, we have normal and choice. So if I run this one, so you will get the first one, you will get the 5 random element, but these will be from 0 to 1 between those. Next, you will get 0 to 10. Okay, size 5. So here also you will get the 5 values, but between 0 to 10. Here 10 is not included, till 9 we will get, but 0 is included. Okay, and here we have range normal. Okay, so it will be 0 to 1, 0 and scale 1 and size 5. So this is what it will do. It will give the value like normal distribution. So it will give the most value to the center of the curve. You know, normal distribution in the later you will see the diagram. Okay, here we have choice. Okay, so here what choice will do, you will give the list of the list, okay, and you will give the size, you will give the replace pause. So this I will explain later. First, what it will do, it will pick all three numbers from this one, like 10, 20, 30, okay, 40, 50. So it can pick any three numbers from here, okay, like it can pick 10, 30, 50, okay, it can pick 10, 20, 50, like this. Okay, now we have replaced false or true, right? So by default it will be true. So for that we can, if replace true, that means if we are adding getting three numbers, so we can get these three number like 30, 30, 30. Three numbers can be same if we are passing replace true, because it will pick that number and it will assign again, so we will get the number anything. But if we are passing replace true, so what it will do, it will take first 20, then it took first 20, right? What is the remaining number? We have 10, 30, 40 and 50. So it will pick next number from here. Okay, but in the when we have 2, so in this case if we are picking 20, so that time this list still have 20 also. Okay, 30, 40. So that can be picked multiple times. So this is why seed estimating, it's just simply like you can get the uh, same result, same random numbers every time. Okay. Next here we are having simple 20 and simple 20 and p dot array. It will create 20. After that it will get the supple indices. It will supple the indices using this one. Okay. And after that what it is doing, we are taking a train into fraction. So it is trying to divide the data set into 80 into 20. Okay. So integer, train into fraction and samples. Okay. Split point will get. After that train underscore train indexes and test indexes will get. So in this case, so from 0 to split point. What is the split point? This will we get the 80%. So for it will here after the 80 indices, remaining 20 will be here. Okay, so test set will get remaining 20 and we will get the from here. So first you can see we support this one, so you will get the random generator. So you can see support index we have 10, 96, 80. When you saw the arrange, it will create from 0, 1, 2, 3 like this. You can see we have trained 16 sample and test we have 4 sample. Here now we'll visualize the distribution. Okay, so if I run this one, so you can see we have normal distribution this one. So you can see that norm function we are using, that will try to generate most of the number from this center here. Okay, so you can see we are using range normal, location 0, scale 1 and size 1000. So you can see it will create the curve as a normal distribution. So this is we have some unique project kind of example here. So we are cleaning and preparing data set, okay, with NumPy only. So what it will do, it will create default range 7. So we have 2000 simple. Okay, so we normal distribution using this scale and size. Okay, so missing mask, it will check x dot shape less than 0 point. So what it will do, it will create mask and check which if we have any value less than 0.004. Here it will assign np dot nan. Okay, after that it will print x shape and the first 5 element from x, and okay, you can see np dot is nan x dot sum x. Okay, so x is 0 is the row, right, a column. So here you can see we have nan here, so it will check this missing value per column is 5, 12, 9. Next, input missing values from the what the column mean. Okay, so if we column np dot nan mean, if you use np dot mean, you will get the nan, but you need to use the nan mean. Okay, column mean, so axis we are passing 0. If you want to row mean, you can pass the axis 1. So here nan rows, nan columns. So here it will what it will get, it will return like np dot as a nan. So it will return here is the nan. Okay, and it will store the rows and columns. So you can see in the here we have 0 rows, right? So we will have 0 and 0, 1, 2. This is the 2. Okay, number of, so you can see 1 or 3. This is the row and this is are the indexes here. So what it is saying, np dot take column means, so we have calculated column means here, and nan columns, we are got the nan columns also. What is np dot take will do, it will take that column and it will assign that to the column mean to that one. Okay, so if I run this column, this cell, okay, so after that what is saying, np dot is nan x dot sum. So it's checking the nan value and you see we don't have any nan value, right? So it will not returning the 0. Okay, so if I print here, print, so here you can see here the this one 0th one, here you can see we have nan, right? So it will be replaced with the x mean here. Okay, the column name. Next we have standard like z score. Okay, so here we are x dot mean. column mean we are calculating, x dot index column. After that we are scaled x minus x mean divided by x standard deviation. Okay, so we are scaled mean and standard deviation. So this is just rounding to the full round. So here we are creating the plot based on that. So if we run this one, so the plot will be between the x, okay, and the x scale. So you can see the income original scale and the standard gist. Okay. Next we have alternative like mini max normalization. So this is also we need to calculate mini and max. Okay. Here x minus x mini and divided x underscore max minus x mini. This one. We have print normalized mini per column x normalized. Okay. So this is same column based only. We have next one hot encoder. Okay, a category column. So what is the one hot encoder? So this is simply like we have here departments, right? So you can see we have here we have cells, English, ENG, HR, cells. So you can see we have 1, 2, 3 only, like cells, ENG, and HR, right? We have three categories here. So np.unique department, so it will return three category. After that, one hot encoder. For that we are doing department colon unique dot department and as a time, okay, and one hot. So what it will do? It will add the value 1 where this department is, and if it is not for that column, we will see the row, it will get 1. Okay, so here we got the three categories, English, HRS. One not good, it means like if we have, okay, employee 1, okay, employee 1, 2, 3, okay, this employee is in the sales department, okay, this is employee in the engineering department, and this is in the HR department. Okay, so for the first row you will get, you can see in this order, in this order the column order you can see like this only. We keep this like first we have this column engineering, HR, and sales. Okay, and this is the employee one. For this we will get, this is in the sales, right, employee one, so we will get 0, 0, 1. Second employee in the engineering, so here we will get 1, 0, other column will be 0, 0. Third employee in the HR dots, here we will get 0, 1, 0. Okay, so for each category will be converted in the columns, and the value they will have 0 and 1. If that employee in that department, then that value is 1, and otherwise it will be 0. Okay, so this is what is the one hot and encoder. So this is needed because a machine cannot perform the operation on the text, so we need to convert in the integer. So next we have one similarly like bonus. So what we have to do here, using s scale from above, find the rows whose equivalent distance to row 0 is smallest, okay, and excluding row 0 itself. And the single vectorized computation is the core of 1 minus nearest neighbor classifier. So it is saying find the equivalent distance, and that is near like smallest to 0 but exclude the 0. So what it is saying, distance, you can see x squared minus x squared, so 0, and x is 1, and n dot. Okay, next we have nearest argument meaning distance, so it will passing the argument meaning to distance, that one, and it will find the nearest for that one. Okay, so if we print the distance nearest and round, so we will get the nearest neighbor to row 0 is the row 119 and the distance 0.115. Okay, so how this is calculated, this is just getting the distance using this, and it is checking like the 0th one, and you will get the index like n dot array distance. After that it will distance the nearest index and round. Next we have saving and loading data. So we have here np.array, so np.save, so we are saving this npy file and loading the file here. Okay, np.array.equal. Okay, so this is just reading and writing the file. Okay, so here you can see we have np.save bundle.npg, here np.load. Okay, here we have next data type and memory, so we just np dot zeros here, you're passing the data type float 64 here. But when we are np dot zeros and data type float 32, okay. If we run this one, you will see the difference between memories. You can see if we are having float 64, it is 8 MB, right? But if we have float 32, it is like half 4 MB. And this is like little bit recap. When we create views, editing it edits in the original. When we copy, it's independent, okay. And when we use for multiplication this asterisk, so it will not be element wise multiplication, not the dot product, okay, or matrix. For that we need to use at the rate or np dot manuals, okay. Next we have nan. So when if data contain nan, so if we calculate mean or sum, it will be nan only. So for that fix, we need to use np.nan and mean. So this is other fix related to acceleration. Next, little bit this what we learn in this one. So for create, what we use arrays, zeros, ones, full I, arrange, and linear. These functions are used to create the NumPy array. We have for inspections. So like we want to check, say, dimension size, data type, item size. For this, we have these functions. Next, like filtering or indexing, we have like direct index like this. Directly we can use mask, we can use np.var or agent, right? We have math operator like plus, minus, multiplication, division, power. After that we have function for square root, exponential, okay, log, abstract value, round. For aggregate we have dot sum, dot mean, dot standard deviation, okay, mini, max. And for missing data we use is nan or nan mean, nan sum. For reshape we have dot reshape, reveal, flatten, dot t for transpose, okay. Combining for we have an np dot concatenate, b stack, h stack, and b split, and np dot h split. So b stack we already know it will like stack rows, h stack it will use as a column. Similarly np split, it will split based on rows. B h split, it will split based on the columns. For sorting, searching, we have these linears, randoms. So these are the functions that we used and learn in this section, okay. So if you have any doubt, you can ask in the comment section. Please like and subscribe and click on bell notification icon for more updates. Thank you.